Hi, this is Eric, and today I'm going to talk about this article, which is about whether there will be a universal moral code for the decisions that self-driving cars should make when it encounters a trolley problem, or the moral machine survey, which I will explain later. So the trolley problem, which you guys will probably know, which is there's a guy over there that could decide whether the trolley should run through the five people over there, or he could pull the trigger so that the trolley will run through the one guy over there to the right track. And the moral machine survey is a play on this, and it's an online survey. You could do a lot of you can still go online and do the survey right now. It's basically a set of questions like the trolley problem. The example I'm giving on the right is a typical question of it. Basically, you could decide whether the car should kill the five or the one. There are other kind of questions on like this. You can choose whether to kill the young or the old, kill the dog or the man. So from a utilitarianism view, let's say for rule utilitarianism, John Stuart Mill, he might say how the rule is to minimize the casualties. So killing the less is the better. So we should probably go for the man on the right. Well, from a act utilitarianism view, or Benson, for example, let's say that the guy on the right is a doctor or he's a firefighter. So sparing his life might eventually lead to more people being saved, which is, in that case, it's probably better to run through the five people on the left. So, yeah, like from the small example I gave earlier, we could pretty much know that there are all kinds of different viewpoints all around the world, so we couldn't reach a consensus. This is a graph showing how different parts of the world's preference in the Moore machine survey, and the article is basically surrounded on this result. So at the end of this article, the author is saying how that this survey will be really useful in terms of modifying the machine instructions in the future. But ultimately, the biggest claim inside this article is saying how there's no universal Moore code on the Moore machine problem or the trolley problem. So the second article I'm going to talk about is also in response to the Moore machine or the trolley problem in general. This author stands on a different viewpoint of saying how the trolley problem does not help with the self-driving car's development. So in this article, the author will start by talking about how the decision-making process of self-driving car works and compare it to the decision-making process of the trolley problem. This is POMDP. The author claims that this is the major decision-making process of a self-driving car. And so by first understanding what MDP is, a simple example I gave on the left is how AI plays a tic-tac-toe. Basically, it analyzes all the moves that the system can take and play the move that has the highest probability of winning. And so POMDP works like this, which is basically saying how there is a sequence of decisions being made, which is all decisions are made step by step. However, this is a world of uncertainty. So the example on the right side shows a typical scenario of a self-driving car in the middle trying to switch the right lane. The only information given to the car is the view to the right, yet it's not a fixed set of information. It's not always about the man or the car that it sees on the right. It's the entire information that it sees from the view. So this is telling us how the car never has a complete set of knowledge of its surroundings, which is called the dynamic condition by the author. So knowing all these, we can compare between the trolley problem and the reality of self-driving cars. So in the trolley problem, we're given two choices. We can either run through one or five. So the decision is always one way or the other. Well, in the reality of self-driving cars, we're actually making a sequence of decisions. Secondly, well, the trolley problem, inside the trolley problem, we have a set of scenario given. Well, in the reality, we never had a set of instructions that we could base to make decisions because it's a world of uncertainty. Everything is constantly changing. It's a set of dynamic conditions. And the most importantly, the author said that from the original problem of the trolley problem, the decision maker is a man, is a human. Well, in reality of self-driving cars, the decision maker is a machine. So can we really compare these two? So the author's claim summarized, she's basically saying how the trolley problem cannot be, well, it's not really useful when we're trying to develop a machine for self-driving cars. The first argument she made, like I explained earlier, is that the two scenarios don't relate to each other that much. So we can't compare them together. And the second argument she made is that there is no universal moral code to train the machine with. This is basically agreeing to the first article that I explained, that since we don't know the ultimate answer, we can't train the machine. If we don't know the answer, we can't do the math. So there are some discussion that I would like to ask. The first one is there a different way of viewing the trolley problem other than utilitarianism? So obviously the trolley problem is a play on the utilitarianism, but I feel like it's really interesting to view it in other ways. Let's say from a existentialism view, the one I like the most, I could probably say how like killing the 1 or killing 5 is just an unfortunate event, and justifying killing the 1 or the 5 is not going to help with the situation. So there's no point of solving the trolley problem. There are more kinds of answers to these problems, which I feel like is really interesting. And secondly, can we really consider self-driving cars as a decision maker and put them into trolley problems? Obviously, AIs are not humans, right? And third question is that, so people are saying that we can reach a consensus on the moral machine survey because self-driving cars aren't that popular yet. So will we eventually reach a day that we can all agree on a set of ethical codes on this problem? That's all. Thank you for listening.